Let's talk about power loss recovery, the reason you might want to use this feature, some instances where it might not help you, and a few devices that could make it even better. Hello everyone, Chris here. I hope you're all well. And yes, today we are going to talk about power loss recovery. This is a feature that's been in Marlin for quite some time now, and if you don't know what it does, it can assist you in resuming a print after your printer has lost power. It should be able to write a file to your SD card and then recover to a spot where you can continue that print. Now there are some caveats to this. Some printer designs might not work as well as others, and there's some setup that's involved. Also, there's a few pieces of hardware you can add to this configuration to make it work even better. But that's all going to be gone over today. So let's start out with a printer that might not work so well with this feature. This printer right here is the Second SK Go, a fine 3D printer, but you'll notice it is the drop bed type of printer. The print head and all the kinematics are up here on top, and then as you print, the bed will lower. Now, this one does have two lead screws for the Z-axis, but they're 4-start lead screws, and 4 starts are somewhat easy to backfeed. So if you were to lose power, those motors wouldn't be energized, and the bed might fall, and that wouldn't enable you to resume that print in the correct position. Now, there are a couple of ways around this. Now, if you would like to try to use Power for Zoom with this type of printer, the first place that I would start would be look at what kind of Z-nut that you have on this design. By default, this printer has the standard brass type nut, and these tend to have just a little bit more slop in them than some other types, like this Delrin nut. So this nut could possibly keep your bed more stable if the power did go off. Now, it's not going to fix everything, but it might be a good place to start because it's relatively inexpensive to upgrade to something like this. So give that a try. The next thing I would look at if you'd like to use this type of design for power loss recovery would be the lead screw itself. You might be able to get a single or dual start screw. Those are going to have a lot finer thread than a 4-start, and it's going to be harder to backfeed one of them. Just the weight of the bed will spin these two 4-starts, but it might not be able to do it on a single or a dual. So you could go that way. Now, other than just the weight of the bed moving the screw when the power goes off, there are other things that could be a problem. One of those being sensorless homing. Sensorless homing is a feature we see on a lot of the smart drivers nowadays. It enables you to remove your end-stop switches. The driver is smart enough to know when it collides with the end of an axis, it will stop, and that's how it knows where home is. It gets to the end of the gantry, stops, that's where home is. The problem with sensorless homing is it's not as accurate as the end-stop switch. And when you have power loss recovery enabled, you are going to have to home X and Y once the power comes back on, so it knows where to go to resume that print. And if it's not really accurate, you might not go back to the correct spot. So I suggest you always use end-stop switches with this feature. So those are some things to consider when looking at enabling power loss recovery. I wouldn't go with sensorless homing. Stick with the end-stop switches. They're going to be more accurate. And consider your printer's design. Maybe your bed's not going to be able to stay in the correct place long enough to recover that print. Also, the bed itself might be the problem. If you're using a heated bed and you take an extended power outage, sometimes when that bed cools down, it's going to automatically release the print, and then you can't recover it. So take all these things into account. You might want to go with a different bed surface if you enable power loss recovery. But with all that said, what kind of design works pretty well with power loss recovery? The traditional bed slinger. Like this Ender 3 that we're going to be using to set up power loss recovery today. There's a lot less of a chance in this design with the V-slot wheels and how it's configured for Z to drop when the power goes out. Now you can re-home Z on a setup like this, but most of the time if you have a print on this bed, you would collide with it. So that's not always the best solution. And of course, there's a lot of different ways to get this done. You don't have to use power loss recovery, especially if you had something like a UPS. That would give you some batteries. If the power did go out, it would give you some time before the printer lost power altogether. But even if you do have a UPS, there's a better configuration you could consider, and that's where the meat of this video is. You have these modules like this one here from BIGTREETECH, and basically it's just a bunch of capacitors. These modules are relatively inexpensive, around $15, but it will store power directly off the back of your PSU in these capacitors, and then you will feed it back to your PSU rail, and you can hook it up to your main board and configure Marlin to send a kill pin signal so that it knows when the power goes out. It will allow you to stop and shut down your machine, and this will store enough power to get you through even a few power blips. They will last for a little while. Also, if you're going to use one of these modules, it is pretty much mandatory that you have something to cover the back of it. It is just a bare PCB. You don't want to short anything out. So bare minimum, print one of these cases. I'll leave a link in the description. This one also has a cover. That can be handy just to keep hands out of there. Tuck it somewhere on your printer where it's out of the way. You should be just fine. And after some configuration tweaks and some testing, this BIGTREETECH UPS module actually works pretty well, better than I expected. But remember, you have to consider your printer setup. But even if you had a UPS with some batteries in it, that would get you through the initial power hit, and then as a failsafe, if you ran out of battery power on your big UPS, this would take over and still allow you to recover that print. But it works just fine without that backup UPS as well. So now we're going to take a look to see how to get this whole thing set up, and then we'll move into the firmware config. So to show you this config, I'm going to use my backup power supply just so it's easier for you to see. Now imagine you have AC coming in over here, and then this feed goes out to your printer. These PSUs will tolerate a certain amount of current coming back into the power supply on this strip. Now I wouldn't want to do it for an extended amount of time, but for this power loss recovery setup, it should be able to tolerate it. Most of these PSUs, it doesn't matter which output you use, they're all going to be the same. And this is a 24 volt power supply, just like the one that is used on the Ender 3, and this module is a 24 volt module. They also do have a 12 volt one. And just for reference, here's a look at the 24 volt version and the 12 volt version side by side, just in case you want to check them out, links in the description. But make sure you use the right one, and fair warning, make sure you get these hooked up correctly, because if you swap polarity on this terminal, you will instantly blow it up. These are pretty well marked on mine. This side is positive, this side is negative, and then you're just going to add this right in on your rail. So whichever ones are available, make sure you get the right one on the right side. We'll put this one on a positive, and then this side on any one of the ones that's negative. So when your PSU powers up, it's instantly going to fill all of these capacitors, and then when you lose power to the PSU, this will step in, use that stored energy to keep you alive long enough to react. Now the other piece of this is this terminal right here. This is used to send a signal over to your printer's main board to tell Marlin, hey, there's been an event, we need to do something about it. This should be 5 volt, ground, and signal. If you're using the cable that BIGTREETECH gave you with this module, the small dash, that's positive, X is ground, and then the longer dash, that is signal. And nowadays, most of the modern mainboards, they're going to have extra pins that you can use for this. You don't have to necessarily have a dedicated power detect pin. So we can assign those in the pins file in Marlin. Just grab any that you have open, but you will need 5 volt, signal, and ground for this to work. Let's take a look at a couple of boards and how you'd hook them up. Here's our BIGTREETECH SKR2. They have dedicated power detect pins, and that's how they're set up in the pins file in Marlin. That's these pins right here. But if you don't want to use those, any of these in-stop pins would work just fine. It's going to work the same way. Here's a newer version of the MakerBase Gen L board. This is version 2.0. You're kind of in the same boat as that SKR board. These are all marked for min and max in-stop pins, but you could reconfigure these in the pins file, no problem. All the pin numbers are on the back of the board. So any set you want to use, anything that's open, go ahead and give it a try. Same way with the old school boards, like this Gen 1.4. You can use any of those in-stop pins that you have open. Just assign it in the pins file. Same way with ramps. It's all going to work the same way. And for this board, the Nano E3 board from MakerBase, I have this on a couple of Ender 3s and I really like it. We're going to use these pins right up front here. These are the default power detect pins assigned in Marlin. Same kind of deal though, the badging is on the back. Use whichever pin number you would like. So cable it to whichever 3 pins you want on the board, cable it on the side of the capacitor module. You have signal, ground, and 5 volt, and you should be good to go. So the main board really doesn't matter all that much, as long as you have a couple of open pins. And going for those unused in-stop pins is probably the way to go. Some of the older school boards might not have enough free pins to do this, but anything more modern, you're going to be just fine. The real magic is in the firmware config. So now let's take a look at Marlin. So here we are in Marlin, and this is the configuration_adv.h. Now I am assuming you already have a Marlin config that works for your printer. We're just focused on power loss recovery for this video. I am configured to use that MKS Robin E3 board. So in configuration_adv.h, just do a Control F and search for recovery. Now you will notice pretty much everything is disabled by default for power loss recovery. So the first line here where it says power loss recovery, we're just going to remove the comment to enable it. Now the default mode is assuming that you don't have some sort of device like we've set up already. You're just trying to use the SD card to save the layer that you're on really fast before the power goes out. And it works sometimes. Remember, in this mode, you will have to redo the entire layer because it only writes a stop point to the SD card every layer switch. So no matter if you are going to recover, you might be redoing some parts of that previous layer, which could turn out okay, but sometimes can be a mess. So it's a little bit dicey in this mode. Now you can have this write to the SD card more frequently. And if you would like to try that out, you can check out the config file, open up source, src, feature, and then scroll down to powerloss.h. In this section right here, you can open up some settings that will make the power loss recovery act differently. You can turn on debug with this line right here. Instead of saving just every layer, it will save every command, which is going to be really taxing on your SD card, but it would be more accurate if you had power loss. And you can also set it to save this information at a certain interval. Now remember, this is milliseconds. So if you think every move is just a little bit too much, you can use this option and set it to whatever state you would like. Maybe 2 or 3 seconds would be acceptable. That's up to you. But by default, if you're not using one of these devices, like a UPS or this capacitor module, it's going to copy every layer. Every time it moves up in Z, it will write something to the SD card. So this will work in some cases. I have had success with this saving a print. But most of the time it only works on 24 volt printers. It doesn't work very well on 12. For some reason the 24 volt just has a little bit more oomph, and it can get you over that line so that it's able to save it to the SD card. But every printer is different, your mileage may vary. Using one of these UPS modules, the capacitor modules, it works a lot better. So that's how we're going to configure this today. So we've already enabled power loss recovery by removing that comment. The PLR enable default set to false. You can do this, you can enable it on the LCD screen, but I want to use it, so I'm going to go ahead and make it default true, so it will be enabled without having to alter anything on the screen, or save an EEPROM. The next line is going to tell it that you have some sort of backup power supply, and that capacitor module counts. This will let you use a lot of these other options. So we're going to remove this comment. The next one, power loss Z-rays. This is crucial. In the default mode, you're not going to get much Z-rays because you don't have enough power to make those movements. With one of these modules, you can raise it pretty much however you want. You're going to get several seconds after the printer gets powered off to make these moves. I just leave it at 2 millimeters for default. It seems to work just fine, and it keeps the blob off the printer. More on that in a second. Then you need to select your power loss pin. We'll take the comment off of this line. Here's where having different boards comes into play. You need to figure out what your power loss pin is going to be. If you use one of the other pins, like a Z Max in-stop pin for instance, you're going to have to tell it which pin you used. The easiest way to do this is to go to your pins file. So pop open source once again, go down to pins and expand it, and it's divided by your processor, whatever processor you use. For this board, we have an STM32F1. We'll expand that. And we have the MKS Raven E3 board right here. Now they share a common file because there's a couple of different versions of this board, but I'll show you that. So let's just open up the file for our board. You can see it has an include statement of common.h. So we'll open up that one. And here's all the pins that we actually need to adjust. So if you scroll through, you can see your in-stop pins. So for example, like I said before, if you wanted to use one of those pins, this is the pin number that you would put in the config_adv.h file. This one does have a power detect pin dedicated, the one that we've got it plugged into on the board. It's listed under power supply control. You could also use that as a PS on pin if you'd like. We are after the kill pin right here. That is PB10, power detect. You can also search on the internet. Most of these manufacturers have a GitHub where you can get these pin locations if you don't know the number or if the badging on the board isn't right. But we're going to go with PB10. So back to configuration_adv.h. Our power loss pin right here, we'll change it from 44 to PB10. So now we know which pin to trigger. Then you need to know what state the pin's going to be in when the power is lost. So we'll take the comment off of this line. And this BIGTREETECH module and this board, they both expect high when the power goes out. So we'll leave that high. If it went down to ground, you switch it to low. We are also expecting there to be a pull-up resistor on this pin for this type of module. So we're going to uncomment the pull-up. Some might expect a pull down. That's this line here. But only use one. And these two lines are actually pretty important that I found for my printer. You need to adjust them per printer basis. But we're going to take the comment off of both of these lines. Since we have extra power when the power goes out, we can make a few different actions. And it's really handy to bring the filament back up or retract it and then purge some more when the print starts. It's going to do the purge at 00 before it heads back to the print to start it again. On the Ender 3 with the stock Bowden setup, I found the purge length of 15 to be about right, and the retraction of 10 to be pretty good as well. This keeps it from blobbing on the print after it stops. It lifts it 2 millimeters like we saw before, brings in a little filament, and it prevents that oozing. Play around with it depending on what printer you have, but this seems to work pretty good on the Ender 3. This section right here is used in the default scenario if you don't have a UPS. You're just trying to write to the SD card quickly and recover after the fact. So it has to move Z up a certain amount before it will do that last save, that power loss data. And it's set to 0.05 of a millimeter. So it has to have enough power to be able to complete this movement before it snaps that last data. And that's not very much. It's still probably going to melt your print at least a little bit or leave a blob, but it is better than nothing. So play around with that. Since we have a UPS, the capacitor module, we're just going to comment this line out. And then finally, this enable Z homing if power is lost. This is what I was telling you before. You can go ahead and home Z in that scenario where your bed might have dropped. If you are able to home without colliding with your print, this might be useful. But most of the time, you're not going to be able to do that. It's going to collide with the print and cause all kinds of problems. So for most people, just leave this alone. You're not going to be able to home Z. you're going to have a printer that keeps that Z stable. The Ender 3, you shouldn't have to worry about it too much. But this is a complete config, and you should be able to use power loss recovery, no problems at all. Go ahead and save, compile, and upload it to your printer. But with that little bit of setup for this module and the configuration that's been compiled and uploaded to the printer, we should now be able to use power loss recovery seamlessly. However, I do recommend that you upgrade to the newest version of Marlin. I am currently on 2.0.9.2. I have had some unexpected results with the previous versions of power loss recovery, but it has been greatly improved. So if you need an upgrade, now is the great time to do it. But let's go ahead and give power loss recovery a test. So the first thing we'll want to do is make sure power loss recovery is enabled. It should be, since we set that option to true in the firmware. Let's go ahead and check it. You can go into configuration and just make sure it says power outage on. You can always save this setting in EEPROM. So if you change it, just scroll down and hit Store Settings. That'll save it to EEPROM for next time. Next, you will notice there is a red LED on our power module, the capacitors. That means it's charged up, ready to go, in case there is power loss. And to give it a test, we'll just go ahead and kick off a print. So we'll let this benchy get a couple of layers in, then we'll kick the power off and see how well it can resume. So our benchy is a couple layers in. We'll just go ahead and kick off the printer's power switch. It was detected. It lifted 2 millimeters. On the screen, it does report the outage, and it does a printer halt. This is how you know it has saved that information, and you're going to be able to resume it when it comes back up. When the power comes back on, you will get the option to resume or stop it. We'll hit resume. It's going to start heating the bed first, then it will move to the hot end. So when we power back up, it should home X and Y. You notice we did leave a little bit of blob. You can adjust that in the firmware depending on your printer. You might be able to get it a little better. Most of the time you can tolerate a blob like that. But we'll head to home X and Y. Then we're going to extrude some filament to make up for that retract that we did when it powered off. It does go a little bit faster than I like. It kind of skips. That would be nice if it was adjustable. But now we go right back to printing where we left off. And because of that blob, it might trip a little bit, but again, most of the time it's tolerable. So there you go. Everything you need to know about power loss recovery in Marlin firmware. And there are a couple of different hardware options you could go with to achieve this same result. But this should give you enough information to get things set up and hopefully save your 3D print the next time you have a power outage. Hopefully you found this helpful. That is it for today, and I'll see you very soon on the next one.